Hello, welcome to Talk Julia. My name is David Amos, and today I am joined by Bogumił Kamiński. Welcome, Bogumił, to the show.
Thank you, David, for inviting me, and hello to everyone listening to our talk.
Yeah, this is great. We're very excited to have you on and talk about everything you've done for the Julia community and doing with Julia. I think most people that know who you are aware of you because of the DataFrames.jl package, but you've also got a book that you've been writing as well. So we're going to talk about that a little bit later in the show. And this week, my co-host Randy is not going to be with us this morning, so it'll just be Bogumił and myself. Well, to start off, Bogumił, why don't you tell us a little bit about how you got into programming in general, and then maybe a little bit after that, how you got into Julia.
Okay, thank you for asking this question. Actually, some time ago, I have written it down in Julia Discourse, which is kind of interesting because Julia Discourse is an excellent place to learn Julia, but it's, I think, also a very nice community, which is one of the things that is really great about Julia. But let me start with sharing you the screen where I live and where I am now. So I am in Olecko.
Okay.
It's northeastern part of Poland, and I grew up there. Olecko is under 20,000 people, and maybe you don't see this, but it's like pretty remote from any other big city in Poland, and in particular or in the world in general. So what is interesting, how I started programming, so it was like probably 30 years ago or maybe more. So because I live in such a city, actually I started programming before I had a computer. So I found a book in a library, and again, let me just screen share because this is a pretty well-known book, but I think it deserves being shared. So I found the C programming language book in the library,
and my goodness.
And I read it, and I learned programming, without even having a computer. So I just learned programming by reading the C programming language book. And probably many people at that time also studied this book. But it also gave me some structure of thinking about coding. So this was a starting point. I started with this book because I was quite into mathematics in general, and later, many years later, actually, I decided to write a book about solving mathematical problems. And it was released 2 years ago by CRC Press. So let me also just screen share it so that you can see. And I will tell you why I'm sharing this, because so this Train Your Brain book is purely about solving mathematical problems, but as you can see here, it has a Julia language companion. So I have now switched from C to Julia. It's an open access just book, like 50 pages of simple introduction to Julia. But why I think it's relevant, because I started with mathematics. I learned programming without having a computer, but what I find when doing mathematics is that really using a computer helps you a lot, either to build an intuition or to solve problems that are harder than can be solved using just pen and paper. And essentially, this is what I do in my life. So currently I am employed at Warsaw School of Economics as a professor, and I'm doing research in quantitative methods, mostly applied to economics and managerial problems. And this gets us to your second question. So how I got into Julia, because as you saw already, I started with C. Then I had I have used different languages, and probably some of you already have seen what I have posted on Twitter when this talk was advertised by Julia Talk. I did a simple chart of what languages I have used in my papers year by year. So Julia is blue here, and as you can see, so I am doing mathematical modeling, either machine learning or simulation or optimization. Actually, those are the three major things I do. And in the past, so before I started with Julia, it was like I was mostly using R for data analysis, and I was using Java for developing custom algorithms. Why Java, not C? Because still, it was a bit easier to code things in Java. But as you can see, like over the years when Julia came, this Java gradually disappeared. It got replaced by Julia, but it not only got replaced, but as you can see, I would say the productivity increased a lot.
Yes.
And I think this is kind of a relevant thing. So what Julia allowed me, it's not that I stopped using other languages. As you can see, I sometimes use Python, sometimes use different languages, but in general, most of the time, Julia allows me to do things, first of all, end to end. So both, high level glue code for convenience, data analysis, and this kind of stuff. But also in the same language, I am able to develop complex custom algorithms that previously I was using either C or Java, or in general, this class of faster languages. Now, what I was able to is switch from using, of course, still, as you can see, I use multiple languages, but like I do majority of my stuff in Julia. And this is, in short, the my story why I have started Julia. Just, so there are two things to summary. First of all, to increase my productivity, period. The second is that I can use one language both for doing high performance number crunching, multi-threading, distributed computing, and all those stuff. But at the same time, with the same language, I can write glue code that, allows me to produce plots like this one. This plot was created with Julia.
Yeah. And there was a comment underneath that by Thomas Polson that said, "I'm curious what the other is in that chart." And I'm curious as well. It's kind of a gold, brownish gold color in the chart there. Could you talk a little bit about what falls into that other category?
Okay, so actually, I don't remember if I have answered this question, but so I will answer it right now because I have missed it. So this other is Stata. And actually, Stata is it's relevant. Why? Because why I use Stata? Because Stata has some features that are not available in any open source package. So for some very specific econometrics, for example, functionalities, one needs to use Stata to get or at least you could write it from scratch, but in Stata you have just it ready. So thank you for raising this. I will answer on Twitter. Now I see that I missed this. Yes, so this is mostly Stata. And as you can see, I just started it most recently because in general, reviewers in journals get more and more demanding of how advanced analysis you present to accept papers.
So I'm curious to know, kind of going back to reading this famous C book, how old were you when you found that in the library? Were you still like a young child as you were reading that, or roughly what age were you? Do you remember?
Yeah, I was around. I was a teenager. I don't remember. It was like 12 or 15. but a teenager in general. Oh, and actually there was the second book, because there were two books now. When you asked this question, I started thinking the second was on Algol. But I dropped Algol very
Okay.
fast because it was not used anymore, or almost
Yeah.
not used anymore, even back then. But C is strong still, even currently, which kind of helps me because I also teach a lot. And student asks me, okay, why do I teach Julia? And there are two answers to this question. So first answer is, and my friend Przemysław Szufel, who is also quite active, especially on Stack Overflow, some of people might have seen him. He tells me that his answer to this question is that he is apart from being a researcher, he does sometimes also high level complex modeling for enterprise customers, and he says, I use Julia because I make money with it. And again, so this is his answer, that it is a productive language allowing me to do complex things fast and deliver good quality products. So this is like one part of the answer, but another part of the answer, and I think many people from Julia community would hope and think or hope would agree with this, that when you learn Julia, you become a better programmer. So when people come from R or Python, I tell my students, learn Julia not only because you can use it, but because you will learn things that will benefit you in many ways in the future, because you will get a better understanding of how in general you should do programming. Because in R or Python, I'm just referring to those two because those are probably most popular in data science ecosystem. Many things are hidden away from someone who is learning the language, and you do not learn many concepts that are essential to general understanding of programming. And in Julia, because if you want, you can go much deeper down into, especially when you want to do high performance computing, you will learn a lot of things that are really relevant when you want to have efficient code. So this is kind of other benefit of learning Julia, that it gets you ready to learn other things of whatever might come up in the future. It gives you a solid foundation and understanding of computer science in general, I believe.
Yeah, I agree. And I think in general too, just learning multiple languages is beneficial because, well, you expand your toolkit and your knowledge a little bit more, but you also kind of learn, um, it sets you up in the future for when you're presented with a problem. If a particular language you're using is not suitable to it, well, if you've already learned multiple languages, it's not quite as scary than to maybe I need to go investigate some other language that would be better suited to this problem. And so I think, just in general, like you don't have to be an expert in every single language that you learn, but just knowing a little bit about other languages, I think is just a useful thing to have done and a skill to have.
Yes, exactly. What I think is important, first of all, as you saw in this chart, I still use different languages, but it shows
Right.
that when so it's kind of, I could say, I hope, pretty experienced. So I know quite a few languages, and this chart shows that actually what I choose when I know from from the options that I choose. So sometimes I, of course, choose something else, but most of the time currently the maturity of Julia is enough that I choose it as a tool of the first choice.
So I'm curious to know about this kind of the story behind like DataFrames.jl and how that came about. And I don't really I don't really know too much about your own involvement in that. So could you just kind of talk about how you got involved with all of that and the whole Julia data organization around that?
Probably, especially in early days of Julia, most people came to Julia because of this speed of promise of speed. So that I
Right.
started with Julia 0.3, so it was really back then it was a promising languages, but many things were missing. I already
Yeah.
could do this number crunching part of my job with Julia, but then I would be still in this part where I was mixing, for example, Java and R. That, I did something in Java, but then had to switch to R. And it kind of was, the more I was doing this high performance computing with Julia, seeing that it's an interactive language. So you had an excellent podcast about using Julia REPL recently.
Oh, yeah. Thank you.
It is like natural to say, okay, let's have this data scientist facing part in Julia well developed, and because in every such ecosystem, a data frame is a pivotal object and that you want to use. I thought that it's worth to start investing time into making sure that data frames are usable, fast, and convenient to use. So and actually, when I started using data frames, my mindset was the following. So I wanted to bring two things into data frames, and I hope users would agree that we at least partially succeeded with it. So first of all, to make it production ready, and the second, to make it consistent with Julia base. What I mean by this, and those things are related. So what we wanted to achieve, and I wanted to achieve, but I hope other maintainers agree, is that when you first learn Julia, like you go through the Julia manual or other books, learn it, and then you start using DataFrames.jl, for example, package. So the first important principle that I thought is really relevant, and there were many changes especially in early days I did in data frames to go this way, is to make sure data frames work the same way as base Julia. So for example, if something, for example, broadcasting, we have broadcasting in base Julia. Now, if you think of how should broadcasting work with a data frame object, to make sure that once you get the principles of the base Julia, it should be natural follow-up how DataFrames.jl works. So there is no surprise. You do not have to learn additional things because things work the same way as you already would expect them. And the second part, is this being production ready, which means that if we add anything to DataFrames.jl, we really put a lot of emphasis to make sure that the design is consistent. So this is the first part, and the second part, that we really provide an adequate test coverage and documentation coverage for any functionality we add, which means that especially after we are past 1.0 release, that users can expect that if we expose some functionality, it is fully tested and it will be stable in long term. I think, in the past, sometimes people complained that Julia packages change their APIs all the time. So with DataFrames.jl, we kind of decided, okay, let's freeze something. Maybe, there are some edge cases that are not super nice, but I hope there are not many such cases. But at least if you develop something in DataFrames now, in 5 years it will work, and it will work without errors. So in a sense, DataFrames.jl, to summarize, is not a super fancy package that shows full power of Julia, I would say, because there are many other packages that, for example, with SciML, what Chris Rakauskas does, amazing things that you would say, okay, it's unimaginable. But then, on the other hand, you need also packages that are boring. And I want DataFrames.jl to be a boring package. Nothing excited, but still people use it because it's just, convenient. I say that it should be a perfect sidekick to any data science project. So it's not, the star players. Star players are those packages, Jump. There is also a podcast on Jump, or you have these differential equations or Flux or whatever. Those are star players. But those star players need a sidekick, to read data in and then to post-process it to produce some nice charts or aggregations or summaries. And this is where DataFrames.jl place is, and still I think it's a boring package, but on the other hand, it's, I think, super important for the ecosystem as a whole to make sure that people can conveniently use Julia.
Well, you say it's a boring package, and I understand why you say that. However, a while ago now, on Twitter, we asked people to tell us what are their like favorite Julia packages. And I think DataFrames.jl it was probably the first or in first or second place. It was one of the top two that everyone mentioned that I they use it all the time. And yeah, I wouldn't understate its importance. I think it is, an important part of the ecosystem, even if it, like you say, it's not representative of like the full capabilities of what Julia can do. But like you said, it's a useful part and important in that aspect, because, especially if you're coming from, if you're a data scientist or a data analyst and you've been working with R or Python or these other tools, and you want to get into Julia, then you're going to want a data frame type to you, because that's just, you're used to thinking with those kinds of things. So
yeah, so actually, but then there is a part of, okay, but what is the future of this? And actually, currently, we are working closely together with MIT Lab folks, but also let me mention one person, Christian Guliński, who is, it's maybe it's like a coincidence. Christian is now part of Julia Computing, but he's from Poland and he's living in Warsaw. He is working on D-tables. This is currently a part of Dagger.jl package, which is in general, so D-table is a distributed table. There were some benchmarks presented in late December that it's also really fast. But what is interesting that it's like one step forward for data frames to make data frames be able to process out of core data on clusters. So this is kind of thing that, we started with data frames, which is an in-memory package, but then using almost the same concepts, and maybe this is not available yet. That's why I'm saying it's a future, but we are in deep discussions with Christian that he tells me, and we are designing it, that the same set of functions that DataFrames exposes for in-memory datasets, to make sure that with the same syntax, you can now go further and just, if your data does not fit into RAM of one computer, you can use the same syntax and just distribute it. And this is, so for me, this is super exciting, because we had something, and the power of Julia is that you can keep the same syntax and just change the object. It will not be a data frame, but it will be a D-table, so distributed table. But the rest is just handled, I would, magically, maybe it's overstatement, but like handled by Julia. So multiple dispatch takes care of everything else. You say, okay, this is a distributed table, not in memory table, but all the rest is essentially or hopefully almost the same. And this is something that is super exciting, and I think very powerful in Julia, that you get a consistent ecosystem. That when you learn something, that's why I started with this base Julia. So I say learn base Julia, then you should have an easy time starting with DataFrames.jl. After you learn DataFrames.jl, hopefully in 6 months, you will be able to do the same out of core on many computers with data larger than RAM in the table, because Julia is capable of doing this under the hood, and you won't have to think about it, how it happens.
Yeah, the multiple dispatch system, the deeper I get into Julia, so my background is primarily in Python. And when I started learning Julia, you hear about, multiple dispatch, and you think, you see some examples and think, I mean, that's cool. You're sort of like overloading these functions and things like that. But the deeper I get into it, I think the better my understanding gets, the more multiple dispatch feels like an entirely different paradigm than just what I'm used to with something like Python. And you've touched on that a little bit. What are your thoughts on, I mean, do you think that's something that is sort of like the key to Julia, like this multiple dispatch system that they have, and how important is that in something like DataFrames.jl?
Because this is probably a super long story, but let me tell you how it is relevant for DataFrames.jl, because I think it shows best how far you can go. So we implement DataFrames.jl in a fully generic way. So what it means that users can supply columns of a data frame that can be of any type of vector, any type of data stored in this object, which means that if you have some very specific requirements, you can just fulfill it orthogonally to the DataFrames.jl package, because we do not, so we can evaluate everything equally efficiently, no matter what type of data we store underneath. And this is significantly different from any other system, because in other systems, essentially, you have hard-coded, I don't know, strings, numbers, several types, and then you have blob, and everything else is like a binary object, but you don't go into detail what exactly is inside. While, for example, I had a recent discussion with one of the readers, actually reviewers of my upcoming book, this Julia for Data Science, when he says, I need to collect data that is additionally tagged by unit. So, of course, the user says, I want to use unitful just to have units. But then, with data frames, it's completely not a problem. If you want to have units, have units. DataFrames does not know about units at all, but it doesn't matter, because thanks to multiple dispatch, user can store those units in whatever way they want, and we guarantee that they will be processed exactly as the unitful package assumed they should be, because we do not interfere with whatever was defined in the external packages or Julia base. And let me just restate it again. Maybe I'm repeating, but I think it's super important that DataFrames.jl design is about consistency with Julia base. So we do not interfere with anything that works there. So if you worked with unitful and it worked, if you put such vectors as columns in the data frame, you can be sure that it will work, because we do not make any assumptions. And this not making any assumptions, I think, is a huge differentiator from other ecosystems. For example, let me just mention one. So probably many users of Python have heard that recently Polars is a super fast implementation of data frame concept in Python. It's implemented at low level in Rust. But then it makes an assumption that the data is stored in some specific format. So it is fast, but it makes assumptions about how the data is stored. With data frames, we are also fast, but we delegate making sure that code runs fast, not to the fact that we write fast code in DataFrames, but just we delegate it to Julia compiler. So, we just take whatever is given, and we know that Julia compiler is strong enough that it will, in the end, generate efficient code, and it does. And this is exactly this power of multiple dispatch. So first of all, you have composability on the features level, but on the second level, you also get high performance for free, because Julia compiler is able to resolve all those dependencies, and in the end generate fast machine code.
That actually kind of brings us to a point we can kind of tie into the book here and maybe move into talking a little bit about that. So you've got this chart in the introduction that sort of compares the speed, execution speed, or time, really is the better way to say that, execution time of Julia, Java, Python, C, and where you've kind of got C as the baseline, right? So you've got this in terms of orders of magnitude, and at 10 to the 0, you've got a line for C, and you've got different points for different languages. And I thought this was a really powerful chart when I first saw that, because you can see that for all the different benchmarks that you've run here, Julia is within an order of magnitude of C for all the different benchmarks, which is extremely impressive. And several of them, probably half of them or so, are very, very close to that execution time for C. In fact, there's one, what is that, the Fancage
Redux, right?
Fancage Redux, yeah. It looks like it's just sitting on the line for C. It's like right there. But you've got that next to a plot that shows the code size relative to C. And what's so amazing about Julia the first time you kind of see something is it's like, so not only are you getting execution time that is comparable, in some cases equivalent or very close to C, but within an order of magnitude on many of these things, but the code size, which are you measuring this in lines of code? Here's how you're measuring that, or
yes. So this is a standard measure, compressed code size. So let me before we dig deeper into this chart, let me give one comment. For me, the most important part of this chart it is that it was not created by Julia community. This is a fully objective chart prepared based on, as I'm referring it in the here, it's this benchmarks game chart, which means that it was, those benchmarks were there, on in the web even before Julia was invented. So the benchmarks are actually, in my opinion, fully objective. So it's not something that I have chosen 10 examples where Julia works relatively well. The key thing here is that those examples were thought of over many years, but by people that they are somehow representative and objective for different kind of tasks. So I think this is super relevant. And I was astonished, maybe not astonished because I know Julia, but I hope that I would get this result, and when I got it, I included it in the book. So the important thing that, as you say, Julia is almost as fast as C, and the code is in general, except one case, much smaller. And here, maybe let me add one comment, because this is something that DataFrames.jl users always ask, because sometimes we could make some things in DataFrames.jl a bit faster, but then at least this is my thinking. Maybe some of people would not agree with this, but this is my thinking, that if I am within order of magnitude of C, I am okay with it. So if I am like 2 times even 2 times slower than C, then I'm okay with it. What is important for me that I'm not orders of magnitude worse in any case. And this is
Right.
kind also
Yeah.
of what we strive for in DataFrames.jl, because this is an interesting trade-off. Because if you want to get things do faster and faster, at some point you reach a point where either you would have to have very complex API to allow users to specify what they want exactly to have things fast, or your code would be very complex to the point where there would be a risk that in 5 years' time it would be hard to maintain it. So as a side note, in DataFrames.jl, we are sometimes aware we could have done things a bit faster, but if we decide it would be much more complex, then sometimes we say, okay, if it's already reasonably fast, we do not strive for the fastest thing ever, because again, DataFrames is a sidekick. So probably here is not the most performance critical code one wants to write. So this is the first comment to this chart. The second comment to this chart is that what is also relevant is that I could make this chart easily with Julia, which means that it's not only that Julia runs fast, that Julia has small code, but actually if I share you my screen with the source codes of the book, which are already currently fully available for everyone. So the book is now in production phase, but all source codes are already there. So this is the source code producing the plot, and most of it is source data. I can prepare a pretty complex plot in like 20 lines of Julia, but it is also important that because Julia has this interactive capability, it was very easy for me to fine-tune this plot. And of course, Julia is not the only language that gives you this, because, for example, in Python or R, you have the same, but with Python and R, you have the cause that in cases you want something to be fast, you either have to switch to some other language or use some special packages. So this is not as easy as in Julia. So this is one part that I think is interesting. And let me also mention another part, actually wrapping up the whole book, which is chapter 14. This chapter is not yet available on Manning, but it's again already written. And this chapter is related to a case study that I was presenting 2 or 3 years ago at JuliaCon. This is a case study of timeline app. So what this case study shows is a company that is doing a complex financial analysis for their customers. They had the following challenge. They were using one of other technologies for developing their code, and they were then migrating them to the web, because in the end this timeline is an interactive application provided via web. And at some point they decided to migrate to Julia, and here are some of their outcomes. So the response time for the query went down from 40 seconds to less than 1 second, which, as probably everyone can imagine, that if you are waiting for 40 seconds in front of a web page, then this is mostly not acceptable. But not only this, but I think this is super important, that thanks to this, when moving from development to production, they didn't have to switch the language, so that they could just reuse the same language in development as the language they use in production, which reduces costs, reduces time, and reduces number of errors. And what I have in this chapter 14 is I wanted to show my readers that, of course, not a full timeline app example, but something that is a minimal example showing this. So this is 50 lines of code. This 50 lines of code is doing what? It's a full simulator of doing Asian option valuation. So complex financial asset that requires pricing. So this pay of Asian sample is a function that is doing Asian options pricing. And it is efficient, but within the same code, with just a single line, this threadx map, I'm running it on multiple threads. So something, again, that is quite a challenge usually in other high-level languages for data science. In Julia, I said, okay, I want to parallelize those things. Just use threadx map, and I'm using all CPUs on my computer on server side. But this is not the end. I said, okay, but I want to make a web service out of it that accepts JSON payloads and produces JSON as an output. Add another 10 lines of code and you have a web service. And I think this is, I like this example very much because it shows that Julia gives you everything. So you have this, low-level code for fast computing. That's why, for example, here you have this hot for loop, which, as we know, in Julia is fast. And it's not a problem in Julia. Then I can parallelize it super easily. And in the end, I can deploy it in 10 lines of code. And this is something that, I'm super excited about this because it shows that you can do all the things end to end in Julia, which makes my life so much easier.
Yes, that is a fantastic example. And so that's going to be, that example will be in chapter 14 of the book.
Yes, so this is, as you could see, already ready. People who don't, you can read the code, but then in chapter 14, there are all the explanations about the theory and how all those things work. But this chapter 14 is actually the last chapter. So it's kind of summary showing in the book exactly what I believe is the strength of Julia. So that you do not have those compromises that of course, probably maybe there are better things if you want to this or that, but Julia is super powerful if you need to do a lot of computing, but at the same time, the ecosystem is already mature enough, like Genie JL there, what I used for creation of a web server, or for example, DataFrames for data wrangling, or for example, Plots.jl for plotting, that apart from your core stuff that you need to do, you have everything around it to build an end-to-end solution. And this is kind of a message I want to send with this book. So of course, you need to learn the basics of different data analysis parts in Julia, but in the end, why you should use Julia? Because if you learn all of this, then using a single language, you can do projects end-to-end on development, and then migration to production is just copy of a file, not rewriting.
Yeah. And I think it's also important to point out too that so you could sort of make a similar argument for something like Python, which has a very rich ecosystem, right? That, you can kind of do everything. It's got everything. However, if you look at the packages you need to use in Python and you go, look at them on GitHub, a significant portion of a lot of those packages is not written in Python. They're in some other low-level language like C or C++. Whereas if you go to these packages and on GitHub for Julia, then I think all of the ones that you have in that example, they're 100% written in Julia, which I think is another kind of important aspect of all of this. That if there's something about a package that you're using, maybe it's just not quite fast enough for something, well, you can go and look at the source code. And if you're already a Julia user, you can probably read and understand that source code. If you're a Python user and you don't know something like C, C++, or maybe Python, which is used sometimes too to speed things up, you go and look at it, well, you're going to have a hard time understanding what is slowing down your code and what options you have to speed it up. So I think that's another important thing to note about Julia too, that I love about it, that I can just go to these packages that I like and I can see all the source code and read it and understand it without having to sort of switch into another language.
Yes, exactly. And incidentally, this is something I always also discuss in more detail in chapter 1. So this is a comparison of just selected packages from R and Python, which shows exactly this. And here you have the same equivalence in Julia written fully in Julia. So what is also important in this part that you have mentioned, I think it's worth to highlight, as you have said, every software is. So, for example, we try to have data frames as complete as possible, as well documented as possible, as well tested as possible. But in the end, as we know, every software has some flaws. So if something does not work as you expect, exactly as you have said in Julia, it's one click away for understanding why it does not work by inspecting the source code. And you can immediately, of course, assuming you know Julia, you can immediately understand how things were implemented. And then either you understand that you used the package in a wrong way, or you can find that there is something to be fixed. But if you need to fix something, again, this is super easy because you just edit source codes and Julia will recompile it on the fly and you have something that was working. Of course, then I would, at least for DataFrames users, I would like to ask them to submit an issue or a PR if they find a bug, and this is very welcome, but at least you are not stuck that there is an error and you cannot fix it. You can fix it in 5 minutes if you find a bug and you need to fix it. And in software, reality is that bugs, unfortunately, sometimes happen, and with Julia, working around them is very easy, thanks to the fact that most of the packages are written in Julia.
So the book is called Julia for Data Analysis, and you've been, it sounds, I guess you've completed the book now at this, well, I mean, completed in terms of you've got the content, maybe you're still editing or something, but it sounds like you've gotten all the chapters written at this point.
Yes, exactly. So all the chapters are written. And but I think it is a super nice process in Manning. So I have written over 10 books over the years, and like over 100 papers. And with Manning, I have a super nice experience of how the book is developed, because it's different from other publishers I worked with earlier. Because other publishers just took a book from me, maybe did some copy editing, sent it back for me to corrections, and it was published. With Manning, you get the book gradually. So the book is being released chapter by chapter, and the process is something like no more than one chapter per 2 weeks, even if the book is already written. Why? So now we have 3 chapters out of 15. Why is this process designed in this way? Because we want, of course, the book to be available as fast as possible. But now, as readers are reading those chapters, I get a feedback and correct things that are unclear, or possibly there are some errors, so that when the book is finally published, it has a much better quality, because I would say that, of course, I write the book, but this is like a community effort to make sure that the book has a good quality. And if someone wants the book faster, then you can go to MIP and get access to it right now. And later, of course, you will get the full book once it's published, but you can get a preview of this book even before it's out. So if I would encourage everyone who is interested in the things we are talking, that you can go now for a preview, and just you will have once in 2 weeks the chapters that go in here. So maybe let me just spend a few words on what is the structure of the book. So the book is structured in two parts. First part is geared mostly towards people who want to learn Julia. Of course, this is all around data analysis, but I'm mostly focusing on teaching how to use Julia base correctly for data analysis, because you can get very far with basic functionalities that Julia already provides you almost out of the box. And of course, I hope that even people who know Julia will benefit from reading this part, but this is especially geared towards R or Python users that want to switch to Julia. And then in part two, I'm focusing mostly on how to work with data frames, aggregation, transformations, and different things, concluding with this web service example. And the other thing I show, and I think it is also interesting in terms of Julia in general, that and also this is one of the later chapters, is in chapter 13. I show how Julia can be integrated with Graphs.jl. So again, data frames can be integrated. No, it's not chapter 13. Sorry. So one of the chapter, I think one of the later chapters is I discussed there. Okay, you have a data. I analyze GitHub developers graphs. So we have GitHub developers, and we check who works with whom on the same repositories, and you want to analyze such data, which is naturally represented as a graph with Graphs.jl, also a very nice package. And then I show how easily you can integrate those two packages. Again, those packages do not know about each other, but then you can very easily, read in the data to a data frame, then create a graph out of it, and then transfer back what you need from the graph analysis results into a data frame to do some machine learning, actually, not analysis. Maybe one thing for potential readers of the book, I do not go too deeply into machine learning. So there are a lot of other excellent resources for this. I rather focus on more basic, I don't want to say boring, because I hope you will find the book interesting, but those more fundamental skills. So rather than doing a deep learning neural network, I do logistic regression to show you how you can build model. Of course, it's simpler, but hopefully, in the end, it's just a different model, but the pipeline is similar, and I more concentrate on building data processing pipelines.
Yeah, so I have to thank Manning. They gave me access to the early access version of the book, so I've been able to kind of go through. And like I said, I come from a Python background, and granted, now I've got some experience with Julia, so I wasn't new to Julia going into the book, but I did think it was a very nice introduction to Julia, that starting off, if you're coming from that R or Python background, one of the things I just have to say, one of the things I love about Julia is, the syntax is not, there's not like a one-to-one, bijection between like the Julia syntax and the Python syntax. However, it was so easy within I don't know, I say a week, but really it was only a few hours over the course of a week, like maybe 4 or 5 hours. I was writing fairly complex Julia programs, having come from Python. And so I just felt like that was a really cool, aspect of the language. The things that you just kind of expect to work the way you expect them to. So, but again, I thought that your introduction that you have there to Julia was it touched on all the kind of questions that I had as a Python developer coming into the Julia language. So I think you did a fantastic job with that, and I'm excited to see more of the content as it comes out. Manning has graciously given all of our listeners a permanent 35% discount on their products. We've got a special code it's Pod Talk Julia 22. We're gonna put that in the description, the show notes, and everything on for the podcast and on YouTube. And there's a special link that you use to get that. And then I also want to mention that once this episode has gone live, we were given one code that's good for a free copy of your Julia for data analysis. So when the episode goes live, we're going to do some kind of event on Twitter. I think we're going to have share this episode, like and retweet, and then over the course of maybe a week, as it's had time to build up and more people know about it, then we'll pick someone at random to win that free code. So one lucky listener out there will get a free copy of your book, and everyone else has a 35% discount code. And that's not just for your book. That is a permanent discount, 35% discount, good for everything on the Manning website, books, their courses, and everything that they have on there. So thanks, Manning, for doing that. That's a really gracious offer that they gave us. So some of the final questions here, as we're kind of approaching about an hour now, so I think it's time to kind of wrap it up. But there are a couple of questions that we ask all of our listeners, or excuse me, all of our guests, and I'm going to ask you three actually, because there will be an additional one specific to you. But the first one is, if you're going to write some Julia, which code editor do you use? And I think I already know the answer just from you sharing your screen, but
yes. So I will give you an answer, and I will give you the reason. And the reason is important. So I use Visual Studio Code, and why do I use it? Because if I use it, then everyone who looks at what I'm doing also can easily follow what I do. And this is super important for me in teaching. So I tell my students, learn Visual Studio Code, and then you will know exactly what I'm doing, because it's the same. And actually, Visual Studio Code has a super nice Julia plugin. But the important thing is, in the past, I was using Vim, and it was only me who could follow what I was doing there. When I want some other people to understand what I'm doing, I found that it's much better to use Visual Studio Code. And why I think it is important, because this is the philosophy we have in DataFrames.jl. So it's not that we are writing a package for ourselves. Of course, I also use it, but our intention is to have something that can be easily picked up by everyone, and I hope at least we try to achieve this goal. And this is kind of Visual Studio Code. Probably, for a single developer, there are some drawbacks of it, but from the perspective of working in a collaborative environment, and especially as a teacher like me, Visual Studio Code is super nice.
Yeah, I agree. I've been using Visual Studio Code as a Python developer for a long time, but it's been a really nice experience with Julia too. You mentioned the plugin that they have, the Julia for VS Code extension. Yeah, it's a fantastic extension, and we actually have a podcast episode devoted to that. So we'll link to that for folks that are curious about that. But we went through kind of a whole tutorial on using it and learning about that. But yeah, the VS Code experience is quite nice. The second question is, what's your favorite Julia package?
Yes, and I will screen share it to you. And again, there is a reason. So now, taram. My favorite package is pkg.jl. And the reason is...
That's a good choice.
The reason is that it's a fundamental game changer to whatever you do. So it's another boring package, but it makes sure that when I, for example, develop my book, I am sure that I can share my project TOML, manifest TOML, and anyone, anywhere can reproduce 100% the same environment that I used to develop my book. And if you have hundreds of users, this is super important, because you do not want to hear from them that something is not working because of environment configurations issues. So again, pkg.jl, super boring package, but so important for reproducibility and productivity that I think, if I had to pick one, this is my favorite package.
I am so happy that I'm not sure who at the Julia project was involved with all that. Probably several people, but the amount of thought that they put into pkg.jl is so impressive. They really, I think they learned a lot from looking at the lessons from other languages and other package managers. It is such a frictionless experience using pkg.jl compared to so many other languages out there that it's really nice. And then having that just built into the REPL, having that package mode, I mean, oh my gosh, it's such a productivity boost. Yeah, really fantastic. I think that's an excellent choice. That's one of my favorite packages too.
Yeah, so I think you touched one important thing that I forgot to mention, but I think it's so relevant that I will repeat it. It's a part of the language, as opposed to how you have it in Python, where you have, conda, pip, of course they work, but the thing that it's part of the language makes a huge difference.
All right, so the final question just is really, kind of a final call to action for our listeners. Where can they, well, you've already mentioned, where the book is available. Do you have any information about when the final book will be available for purchase? And then also, where can our listeners get in touch with you or follow you on social media?
As I have said, the book actually is already available. And if you go to Money, so the only thing is that it's not released yet. So you can buy it, you can read it chapter by chapter. The only limitation is that it will be finalized. I hope so my personal objective is to have it by JuliaCon. Probably it's not realistic.
A couple more months.
But for sure, I think for autumn, so somewhere around August or September, it should be fully out. But even now, and I think it's also super nice, because if you look at bestsellers on Manning website, My Julia for data analysis, and it's astonishing. It's fourth, and it is here in top bestsellers. I think since it's since it was first released like a month ago, it's constantly in these top bestsellers. But it's what is also interesting, and I think it's valuable, that there is also a very nice book, Julia as a second language. It's also in MIP, so it's a preview, but it's also constantly in bestsellers, which I think, as a summary of our talk, shows that Julia is really in rising demand, because as we can see, again, it's like objective measure. People are, reading those books. And they have choice of whatever programming language they would want to learn on Manning. But it seems that people really start learning Julia, which I am very happy, because it's always like a chicken and egg problem, that you have a nice language, but you need users to have community. And writing those books is one of the ways I hope to help to build this community, so that more people can learn about how nice Julia is.
Yeah, and like we said, you can get a 35% discount on the book now with the code and the link that we'll share in the description of this episode. So you can go ahead and purchase it with the discount, and then you'll have the final version once it's available. You'll just get the automatic updates. And yeah, we've got the one person that will win a free copy of the book as well. So if you're listening and are not following us on Twitter, please do so. Where it's at TalkJuliaPod on Twitter, and we'll put that in the description as well, so people can see it, so that you can see when we actually run that raffle and give away that free book. And Bogumił, you're also on Twitter, correct? Do you have?
Yeah, so people can contact me on Twitter. I have Julia Slack, which is, I think, the most popular, probably currently method of contacting with me. I write blog, which probably also some people have seen. So let me just again screen share. So the blog is again. So let me stick to this boring style. So the blog is boring because I just made a decision 2 years ago. Write something about the ecosystem we are building once a week. So every Friday you can expect that I will write something about Julia, and this is something I think, and I hope is also a valuable resource for learning, especially about DataFrames.jl, because naturally I write a lot about it. And also, if you have a question, I'm quite often also answering questions on Stack Overflow, so you might also see me there.
Well, Bogumił, thank you so much for joining us. It's been a lot of fun and a pleasure to meet you and just hear about everything you're doing with Julia and for the Julia community. So really appreciate you joining us today.
Okay, thank you very much, and thank you for sticking with us, and I hope you enjoyed the talk.
Absolutely. Thanks.